Good morning, everybody, and I'm very happy to welcome you to ISI for this inaugural event to inaugurate this project called the Dynamics of Agricultural Innovations. It is in two projects in North India and in South India, because for other countries it's one, but for India they decided at least two. We need to be at least divided in two, and they've let us decide where is the border of the south and the north. So that is under so this is a project which is funded by the CGIAR SPIA. So I'll just say a few words about that. CGIAR is this consultative group of international agricultural research, which is a kind of a partnership of international agricultural research centers, 11 today, in different parts of the world. And I thought I'd just say a few words about the history of CGIAR for some of you here. CGIAR in its form actually started in the early 70s, around 1971. In 1970, the Rockefeller and Ford Foundation had these events at Bellagio. They have a Bellagio Conference Center in Italy. They were the key promoters of this international agricultural research centers, but they had many agricultural experts and others with them. And of course, the Rockefeller and Ford Foundation had started funding the work of what became later CIMMYT in Mexico, these dwarf wheat varieties, even in the 1940s, though it was formed as a center later. And early 60s had CIMMYT and IRI, the International Rice Research Institute, and then two more, and then the expansion happened in the early 70s. And Gaurav, you'll be interested in this, that one of the founders of the CGIAR in its present form and who attended the Bellagio conference was this Australian economist and civil servant, Sir John Crawford, who was later Vice Chancellor of ANU and of which Gaurav is alumnus. And then he later became the first chair of what they call the Technical Advisory Committee, TAC. And TAC later, so TAC's goal was, although it was called Technical Advisory Committee, it was to advise on the science, the strategy, the programs, priorities, resource allocation, and later TAC was converted to the Science Council, the Independent Science Council, and it was only in the 1990s that you had this SPIA, which is funding us now. Standing Panel on Impact Assessment was formed by the Science Council in the 1990s. So this is quite history. I think there's a nice connection with ANU and Sir John Crawford in this. Second thing is coming to the role of India. So I think at least particularly people of our age, not the younger people, in the 1960s and 70s, the role of CIMMYT or the role of IRI was known not just to the scientists, but to the cultivators. In fact, in Tamil Nadu, one farmer named his child IR8 and so on. And if you went to Punjab, Mexican dwarf varieties, I mean, they were very familiar with this innovation that
My
was.
hometown is Karnal.
Is it okay? So you must have, yeah. Everybody heard about these new varieties which were coming from the CGIAR, and I think the point is not just the scientists and the administrators, but cultivators, and then of course later general public also. So now we come to the present, and I think now is a more challenging period for two reasons, and maybe this is part of why this project is so exciting. One is that the National Agricultural Research System, or what is called NARIS, and we have a representative from there, so he'll know more than me. You were in part of NARIS in a way, National Agricultural Research and Extension System, has become much stronger. So I think whatever is done by CGIAR institutes is very much in collaboration with, in partnership with NARIS, even the research, not just the dissemination or scaling up. So I think this, the to and fro between the international and the national is perhaps a little more complex now, and we need to study that. And second also, of course, is that it's no longer just seed varieties. There's, innovations are much, more diverse. In fact, digital technologies, and they want us to use new methods like remote sensing and all to gauge what is happening. So I think that's one of the reasons I think this project is going to be quite exciting. And the last thing I'd like to say by way of introductory remarks is that uh, I I'm wish it had been an ISI. ISI had been official partner in the project, but that's not possible because I'm retiring. And 3 years before retirement, as per government rules, you can't take a project anyway. Because not just because of I think ISI would have been a good partner, and we will still partner in other ways. But because the first crop cutting experiments in India were of course started at ISI by Mahalanobis and others. So ISI has been very much part of agricultural research methodology developing in agricultural statistics in India. We didn't have ISRI and all earlier. The ISI was older than them. So I hope that I will get the support of all ISI faculty and researchers in taking forward these new methodologies and so on. So now I will like to ask Professor Daya Sagar, head of ISI Bangalore Centre, to officially inaugurate the project and event.
Yeah, so very nice to be here, madam. So thank you for inviting me here. But what attracted me is the innovations in agriculture. It's such a nice thing because we have been doing those innovations almost for the last 2 to 3 decades, ever since the remote sensing data came into existence. And now we have the remote sensing data available at even centimeter level. And with all that, I worked in a place called Center for Remote Imaging Sensing Processing in National University of Singapore. And there I used to see some of my colleagues used to count the palm trees in Malaysia just by sitting in the room. And then it has a wonderful thing because palm trees are like its canopy is like a semisphere. And then, so what my colleague, associate scientist, one Annie, who used to do is just compute the boundary of that canopy and then find out the centroid. And then all those centroids she used to just count and tell that this is the number of trees existing in this farmer's field. And so there used to be a kind of consultation our center used to give. And this was almost about 25 years ago. And actually all these are there, but it has not brought under one single umbrella. But the recent one, when we have looked at the founders of AlphaFold, a company, AI tool they developed, and then with that AI tool, 200 million protein structures were analyzed in one single year. Had it been with traditional methods, and it should have taken humanly billions of years. And such a huge, I think that is the path-breaking innovation, of course, which won them the Nobel Prize in chemistry. And these are really remarkable things, and I'm sure that such kind of innovations are also there in agriculture, which I'm not an agriculture scientist, but many people who use remote sensing data, they have no connection with agriculture science, but domain expert is very important. And we used to map and we used to tell that so accuracy is very nice, but so that has to be validated by the domain expert, not remote sensing. And this is where, some other data we used to use is like digital surface models and digital elevation models. There is a typical difference between digital surface models means it gives the surface of even trees, forestry and all that. Digital elevation model is typically the ground height from the mean sea level. And if you subtract digital elevation model from digital surface model, it's a simple algebraic subtraction. You will get the canopy height models. So these are straightforward because these DEMs are so accurate now, and with powerful satellites and high resolution sensors. And again, that is one aspect. And then high performance computing in agriculture science. There was a wonderful conference happened a year ago in some hotel in Sajapur Road, and a group of people came from America, particularly from UAUC, and they were showing the automation. Probably India has not come to that level, and they're picking all these mangoes and everything. Robots are picking those things, and these are all operationalized there. And perhaps Madam was telling there is south, north and south. Probably the challenges are different. And some of the farmers who are well educated, highly educated, the kind of questions they are asking, the challenges seen there are completely different from the challenges that he has been seeing in our Western Ghat areas. And he has a wonderful fields, and he is telling that, can we really detect, and then can we really find out the plant growth? I think these are also done by IIST people, Indian Institute of Space Science Technology, Trivandrum. And so they have a kind of prototype model they developed. I think it has happened in University Agriculture Science, I think GKVK. And they used to come, it is an Indo-German project. And so they used to run drones by taking all permissions from DGCA. And then they used to see the plant growth things, and with, very temporarily they used to collect that, and they used to make models. And that is another one. And crop cutting methods, crop estimations. And from remote sensing data, it was coming earlier. This was about 2-3 years ago, and they were telling the accuracy is 70%. But crop insurance schemes and these bankers and these NABARD people, they want that accuracy to be 95, above 95%. Because they are telling that some farmers are cheating them. That though there is no disaster, they are telling that their cultivated field is destroyed. But these are the things. But now with the drone technology, this monitoring of those, crop yields and all that, crop estimation methods are much more accurate. I think there are several startups came. I think one of the startups is cropping. I'm sure you will be aware of cropping. Cropping has done a lot of innovations, and one of the persons I know is one Praveen Pankajakshan. He lives here in Bangalore. And Praveen Pankajakshan has done a lot of work through cropping. I think he is one of the big those things. Yeah, I think with this few words, like let me just formally say that it is inaugurated. Seeing very luminaries here, and I'm an odd man.
No, no, you have just shown that you know a lot about things we didn't know about.
Yes,
Thank you.
Yeah, thank you.
Yeah. I'm sorry, I forgot to do one thing, which is just a 1 minute introduction of our team, because some are online, some are in person. So this project in North India and South India, there are two PIs, Professor Gaurav Dutt from the Center for Development Economics and Sustainability at Monash, and myself here from ISI. Then we have two co-PIs, Emilia Ternstrom, who's a senior research fellow, a new mother, so she's trying to join, but I hope she'll join a little later today, who's one of the co-PIs, and the other is Dr. Sandeepan Bakshi, the director of Foundation for Agrarian Studies. And we have Dr. Sherry Jacob, principal scientist from ICAR-NPBGR, National Bureau for Plant Genetic Resources, because this whole germplasm and the material coming to India from international institutes is going to be key to our study also. And Dr. Dean Jolliffe, the lead economist for the LSMS survey in the World Bank, who will be advising on our large-scale sample survey. So this is the team, and they will all speak later on, but I thought I'll just say one word about it. Now I will invite Dr. V. Surjit, who is a very senior scholar at the National Institute of Rural Development, NIRD, in Hyderabad. As I already revealed, he's an old student, but more importantly, he has worked with the CG institutions, with SIP and CIMIT and ICRISAT, and is, I think, very rightly poised to be able to tell us a little bit about the role of CGIAR institutions in Indian agriculture. So over to you. You have a PPT or something? Yeah, they will share it. Yeah. Okay.
So, good morning, all. Thank you very much. Thank you very much, FAS and ISI, for giving me this opportunity. As Badra was pointing out, I have worked in CGIAR for last almost 8 years. Two centers, one on National Potato Center, which does work on roots and tubers, and Igriside, which largely works on millets and pulses, the semi-arid tropics. Uh, so this is also an opportunity for me to look back. When I was working in these centers, I never thought about what could be a larger macro level impact of these institutions on various aspects. It's also an opportunity for me to look back and see what all technologies CGR has promoted in India. And before going into that, Mother has told about the history of CGI, but I would like to mention a few points about the origins of CGI, just like this. There was an article written by Warren C. Baum, who was the first CGR chair. He was CGR chair for about 10 years. So how it all began. So as mentioned earlier, the early 1950s, Norman Borlaug and George Harar were working with the government of Mexico for short duration wheat varieties as part of Rockefeller Foundation initiatives. And then they discovered, they developed a few short duration varieties which has potential for high yielding. And Norman Borlaug brought these varieties to India and Pakistan and tried in India and Pakistan in the early 1960s. And the rest is history. Semi-dwarf wheat varieties, which is planted in India and Pakistan. He classifies this as the first half of the Green Revolution, which started in wheat. He came to India, met Professor Swaminathan, and then they together started field trials of short duration wheat varieties. So that's the first half of Green Revolution in India. Next slide, please. And so learning from the success in wheat, short duration wheat varieties in the subcontinent, they started thinking, why can't we expand this to other cereal crops? The next potential crop was rice. And they also bought, Rockefeller Foundation also bought in Ford Foundation along with this. The fundamental philosophy by which they thought such an international effort could work towards addressing some of the pressing concerns of the developing world was that many of the fundamental physiological, biochemical, and genetic problems are essentially independent of geography, be it India, Pakistan, other Asian countries. So these characteristics can be addressed without any geographical or political boundaries. And if you find solutions for that, that can revolutionize the agriculture sector in these countries, which can bring in rural transformation. So that was the objective. So they felt that formation of international institutes was the most cost-effective way, which can concentrate on expensive equipment required for this high-end research and assemble talents from across the world to solve these problems. So they work under optimal conditions. So that resulted in the formation of International Rice Research Institute in the 1960s. Although CIMIT started working from 50s, it was formed in derived an institutional form in the 1966. IRI was formed in 1960. So that remained as that marked the second half of Green Revolution. The first variety is IRN, which Badra was talking about. Next slide, please. And then, so CIMIT was a success, IRI was a success, could solve many problems in the agriculture sector in the developing countries. Then they looked at IITA, Indian Tropical Agriculture in 1967 to look at the low humid tropics. IITA has its headquarters in Nigeria. That again was a success, and then Rockefeller Foundation again worked with Government of Colombia to establish SIAT in 1966. So CIMIT, IRI, IITA, SIAT. These were the four lead centers which formed as the global alliance, forming an international alliance for addressing problems related to the agriculture sector. And then again, the meeting which Badra was mentioning about happened in Italy, World Bank, UNDP, FAO, Rockefeller and Ford Foundations with the support of developing countries. If you look at CGR, USA, Canada, and Japan are the lead donors with support from developing countries. So that is the philosophy behind formation of CGR institutions. So if you look at the CGIAR institutions now it started with 16 centers. Now few centers merged together, and now it's 11 centers. If you look at the geographic distribution, we have CIMMIT based in Mexico. So the reason why it's based in Mexico is the center of origin of wheat and maize. They work on wheat and maize. The center of origin of wheat and maize is Mexico. SIP, which is International Potato Center. So center of origin of potatoes is Andes region in the Peru. So you have SIP there. You have International Rice Research Institute at the extreme right, which is based in Philippines. So these are the big crop-based institutions, which focuses specifically on crops. CIMMIT focuses on wheat and maize, SIP focuses on potatoes, IRI focuses on rice. And we have a range of other institutions like ICRISAT, which largely look at pulses and millets in the semi-arid region. International Water Management Institute, IWMI, which largely looks at issues related to water policies and water management, which is based in Sri Lanka. You have International Livestock Research Institute, which looks at role of livestock and necessary intervention in the livestock sector. And you have a range of institutions. ICADA in Syria, it was in Syria, so I'm not quite sure whether it's operating from Syria because of the internal issues there. You have biodiversity, which looks at biodiversity aspects. So biodiversity was based in Italy on the top, right, left, ICADA. But then biodiversity and SIAC, which was based in Colombia, merged and became, they worked together. You have World Fish in Malaysia, which looks at issues related to fishery sector. Down, you have CIFOR in Indonesia, which looks at forestry system. And you have ICRAF, which is the World Agroforestry Center, which is based in Kenya. So again, CIFOR and ICRAF work together now. And you have Africa Rice, which is relatively new, which is based in Cote d'Ivoire. So these are the range of CGIAR institutions at present. So right now around 11 institutions, basically 3 crop-based institutions and other institutions which largely work across the platform. So you have International Food Policy Research Institute, which looks at the policy issues across the sector based in Washington DC. So this is the spread of CGIAR institutions now. So coming to India, well, these 11 CGIAR institutions, most of the institutions have presence in India, but the larger impact of the CGIAR institutions, the work of CGIAR institutions in India largely revolves around these 6 centers. CIMMIT, which works on wheat and maize, I explained earlier about advancements in wheat. International Food Policy Research Institute looking at the policy issues. IRI on rice. ICRISAT on the semi-arid tropics. IWM, International Water Management Institute, looking at the water related issues. SIP, which looks at, it started working with potatoes, but then now it works on all the roots and tubers, including sweet potato and other tuber crops, which is relevant. So these are the 6 CGIAR institutions which have made considerable contribution to the developments in the agriculture sector. Next slide, please. If you look at it in a macro perspective, in a larger way, these are the larger contributions which these centers have made. We can, on each item, we can go very specifically with respect to regions, with respect to types of crops and systems. Green revolution, wheat and rice. Again, the release of new varieties, adaptable to various conditions, still continues, and centers like CIMMIT, IRI, and SIP keeps working on that. You have interventions in the dryland cereals, largely on chickpea, pigeon pea, in varieties in pulses and legumes, new groundnut varieties, new varieties of various peas, largely focusing on the semi-arid tropics. No? And varieties also value chain development on these commodities. You have improved potato varieties, which is suitable for different conditions. Because earlier the potato growing regions largely used to confine to areas in the north, but then it is slowly spreading south also. Karnataka is another hotspot where potato is produced. The issues related to markets and value chain development, because I think when the CGR institutions have started working in India, it was largely a closed economy. It was not a liberalized economy. Trade has not happened at that point of time. In post 90s, when with liberalization, the trade happening, new markets came out, new forms of trade, new opportunities for trade, and as a result of which, the requirement for understanding the markets and value chain development in a better way has arisen. Significant contribution in natural resource management, particularly with respect to water management and soil. Water management, which was largely led by IWMI. Another important function was capacity building of the NAR system, National Agricultural Research System, because since the establishment of NAR, of CGR, a strong focus has been given to train the NAR scientists on various aspects. And what I was mentioning, now if you look at the crop-based institutions, be it rice, wheat, or potatoes, or pulses, the National Agricultural Research System in India sometimes are much stronger than the capabilities of CGR. So now that contribution of CGR is very significant. And we also have, through policy analysis, we have a better understanding of various transformation pathways, particularly focusing on agriculture nutrition linkages, the supply side aspect and the demand side aspect. So these are the broad themes on which there has been significant contribution by CGR in India. And if you come to center-wise achievements, if you looked at, if you look at cement, particularly in the horizon of last 2 decades, basically post 2000s, these are the larger, and these are not based on any serious impact assessments and all, but then discussions with the socioeconomists in these centers have thrown up this list. So maybe this is an exhaustive list, but then more can be added, or you can omit a range of things. So if you look at cement, like other centers, the climate resilient wheat and maize varieties, particularly heat tolerant maize, has been a significant contribution. I'm not going into details of varieties, the numbers, and the names and all. Laser land leveler has been a big innovation in terms of improving water management activity. I mean, if you have a level field, your water management is very effective. There can be a lot of cost cutting, which can contribute to improvements in productivity. Focus on seed value chain. Seed has been a big problem in any crop in India. So establishment of formal seed value chains was an important contribution. BNI wheat, which is biological nitrification inhibition wheat, which improves the nitrogen use efficiency. For example, the crops will have genes which inhibit the process of nitrification. So if you inhibit the process of nitrification, that will improve the nitrogen use efficiency of crops. So you don't need this much of nitrogenous fertilizers to be applied, which can reduce the cost. Also, excess nitrification will create a lot of environmental impact. Nitrogen gets leached out into the water bodies, can cause pollution. So BNI wheat variety is an important contribution. Small scale mechanization across the value chain, in wheat and maize value chains, is an important contribution. The idea of cropping systems, integrating with legumes in crop rotation and along with those crops, has been an important contribution. What they call as regenerative agriculture. So CIMIT has few agronomic practices which combines agronomic practices and mechanization, where, for example, zero tillage. They have a concept called happy seeder. Now, all these technologies will regenerate the natural resource, which is the soil. It also has implications on soil carbon storage. So these range of technologies can, what they call as regenerative agriculture, can significantly contribute to the agricultural production system in terms of its sustainability and improving yield levels. So these are the larger from cement, from AV, there is a larger list again, submergence and drought tolerant, which is part of their cereal system innovations in South Asia project. Hybrid rice seed production, the institutionalization of hybrid rice seed production, particularly with the farmers cooperative and other formal institutions. Largely, this is in Andhra and Telangana states. Direct seeded technology, which International Water Management Institute has a role to play, where you save a lot of water in terms of when you adopt this technology, you can bring down the schedules of irrigation, which will save water at the same time reduce cost. Uh, the biggest criticism against rice has been that it has high glycemic index, which is in terms of health parameters, which is not. So they have come up with a low glycemic index
And ultra low,
rice
low
varieties.
ultra,
Yeah,
for diabetics.
yeah, and then they have started intervening in the value chain. They have started developing, cookies and other things with low glycemic index rice. You have characterization of indigenous rice varieties, Kala Namak in UP and Kala Jira in Koraput. So that is their contribution. What they call as speed breeding pros and protocols. This is I'll come to ICRISAT also. What they call as fast breeding platforms. Now you reduce the breeding cycle. So normally for releasing a new variety takes from 14 to 20 years, from starting from the conceptualization of the first idea, identification of varieties, breeding, and then to release of that variety takes almost 14 to 20 years. So how can you reduce that cycle? When Norman Borlaug used to do what we call as shuttle breeding. So wheat you can grow only on a particular season, but then you can take that seed to another area where similar agro ecological conditions are there, and then you can have two crops in a year. So you reduce the breeding cycle. So he used to call it as shuttle breeding. You take everything to another place and then do breeding. So what CG centers have taken lead in promoting the speed breeding process. I'll explain in detail when I come to ICRISAT because I am familiar with that.
I
And
think
they have
that-
again,
5 minutes or how much? No,
yeah,
yeah.
I'll quickly.
No, yeah, sure, please go ahead.
And you have digital soil map, again, the application of GIS and other things which integrates, which will help in more site-specific nutrient management, which is, and you have biofortified rice, fortified with zinc and iron. Again, low emission rice because of climate resilient agriculture practices. The largest emission of greenhouse gases is from the rice fields for agriculture. So you have practices where you try to reduce the emission from rice fields. So you have water fertilizer management protocols which help you to achieve this. And then again, value-added products, like I was telling about low glycemic index rice cookies, which is a value-added product. Next slide, please. If you come to ICRISAT, largely sorghum varieties, what they call as sweet sorghum, which is used for biofuel production. You have cold-tolerant sorghum, which is largely for J&K and other regions. Chickpea and pea varieties, different, suitable for different agroecological conditions. What they have is a hybrid parent consortium where for sorghum, pearl millet, and PGNP. So as I said earlier, the variety release period is around 14 to 20 years. So when you start breeding process, you may arrive at varieties which others can take up, and then they can take the parents from this hybrid parent consortium. They buy this parent at an intermediate stage, and then they can continue the breeding process in a different direction depending on their requirement. So private companies, they have very segregated markets which looks at specific characteristics. So they may not look at the final product of what the CG system or the NAR system is producing. So they can take parents at the intermediary level, and they can continue their breeding process. So they don't have to repeat the entire breeding process. So that has been a big achievement of IGRISAT. So they make payments to hybrid parent consortium, take these parents, and then they continue breeding in their desired lines. So that's an important achievement. High oleic acid groundnut varieties. For example, they did this for Mars chocolate, where they need high oleic acid variety groundnut, which is good for health. So you breed varieties for that. Again, fast forward breeding platforms. In simple terms, they use phenotypic and genotypic methods. For example, if you use certain markers, you can detect drought tolerance or heat tolerance or specific traits in a crop. So you don't have to, in classical breeding, you crossbreed two varieties, and then you wait for the offspring, grow it again, then multiply. You don't have to wait for that. If you know that this through markers, you know that this variety has a particular advantage. You take that variety in advance, and then you cut down the breeding cycle, the breeding period. So that is fast forward breeding platform. So that is an important contribution of CGIAR. And solutions to combat aflatoxin contaminant, which they have developed kits and then varieties which can do that, and digital agriculture strategies which stretch across in terms of extension and in terms of pest and disease management. So all these in this are contribute to it. SIP largely on heat and drought tolerant potato varieties, orange flushed sweet potato, which has high vitamin A content. But then again, the adoption of that in India is slightly doubtful. And then roots and tubers value chain development. We had a technological true potato seed, and Tripura in India was the largest producer of true potato seed in the entire globe. But now that has been replaced, slowly being replaced by apical rooted cuttings. It's a new technology. Again, it has implications for evaluation, because why that is an advantageous position. It's an advanced technology. It's little doubtful when you compare between TPS and apical rooted cuttings. Largely depends on other conditions, availability of labor, your because true potato seed was invented to address difficult areas. If you want to carry traditional potato seed, you need to have tubers cut into small sizes and then carry it. So if you want to plant 1 hectare, you need around 2,000 kg of seed, which is difficult to carry in places like Northeast. So if you have true potato seed, you can carry 150 grams of seed. You can put it in your pocket, go there, grow it, multiply it, and then spread it. And Tripura has pioneered in that technology with support from CG centers. But then now that technology is slowly wading away. They are introducing a technology called apical root cuttings, which has started very recently. So, but they are doubtful about it. Okay, so again, it depends. You mean largely on water management technologies, what they call as underground taming of floods for irrigation. So when there is excess flood water irrigation, you use mechanisms to divert that to recharge the groundwater so that you avoid floods as well as you recharge aquifers. Uh, they developed index-based flood insurance, which is not successful, which was not adopted. So in areas where which are prone to flood, you have you integrate GIS maps and other things. You identify flood regions and then provide insurance. But then uptake was not that much. You have solar irrigation for agriculture residents, which is slowly happening now, which is in the process. Again, these are activities done by different crop-based institutes, but then there are larger cross-cutting and converging activities which has contributed. Biofortification across all crops, rice, wheat, or millets and pulses, was carried by a platform called Harvest Plus, which is under CGIAR. So they largely focus on biofortification of crops, impact of gender-based interventions. CTR has a gender impact platform, and again, the data systems, GIS, the latest technologies, artificial intelligence, machine learning. You use these technologies to understand various issues in the in the agriculture sector and then try to find solutions to it. So these are cross-cutting platforms. Next slide, please. So these are CGR. There is a site called CGR at 50, which they consider as the major achievements of CGR in India. High iron-rich pearl millet, which was bred by ICRISAT. Zero tillage I was telling earlier. Potato varieties, this flood-based insurance, and incubators for agribusiness, because ICRISAT started an agribusiness innovation platform where they incubate young entrepreneurs to build up the value chain. And then again, ICRISAT's interventions in watershed development is also documented. OFSP, it's a big success in Africa, but then it was introduced with a big fanfare in India. My first job in SIP was to do an impact evaluation, and I went with a lot of excitement to Orissa, Ganjam district. I saw only two farmers, this lady and one more lady cultivating that particular variety. But then much development has taken after that. I think National Agriculture Research System, because India also have indigenous varieties which have high vitamin A content, which is called orange sweet potato varieties. So NARS looked at the potential of it, and then they started propagating their varieties. So that's also something like a demonstration effect which has happened. Again, we don't have any data on how much, even data on roots and tubers are not there, but then leave it on OFSP. So again, impact evaluation has to be done. Next, please. TPS, I can talk a lot about
I
this.
know this is a.
So, yeah,
you're winding up on only a few slides.
Yeah,
yeah.
You need a long daylight for potatoes to bear flowers, because in normal conditions it won't flower. So you give floodlights in the night to give light. Then your potato berries like this looks like tomatoes. Then you harvest the seed. It's like tomato seeds, and then you sow the seeds, grow first generation of seedlings. They produce small seed tubers that will be used as seed. So it's largely to maintain heterogeneity in the population, because potato is largely vegetatively propagated. If you maintain heterogeneity, it can have disease resistance. It won't be wiped off by a single disease. So those advantages are there. So now it's apical root cutting technique. Those who are interested can learn from it. Next slide, please. Again, larger transformations. See, post 2000, as I said earlier, liberalization, opening up of more markets, and then commodity institutions like IRI, wheat, and IRI, CIMMET, and SIP, trying to understand the importance of value chain development. Transformation happening in the post 2000 period. What they have is the larger program. So these institutions were working independently. In 2010, they came together and tried to formulate common programs where they converge. So they have 8 what they call as CGR research programs on agri-food systems, on food systems, and then 4 research programs on global themes, which integrate between them. Next slide, please. So these are all the 8 agri-food system. You have programs on fish, wheat,
I think
rice,
we'll have
maize.
to speed up a bit. So
Yeah. And then you have the 4 cross-cutting programs. Next slide, please. Yeah. So which is on agriculture for nutrition and health, water, land, and ecosystem, climate change, agriculture and food security, which is across the centers. So this is the time when centers started working together, because working in isolation will not help. If you want to look at farming system as a whole, take into account all the crops, you need to work on common platforms. So that was the idea. Next slide, please. Then now, 2022 onwards, you have what they call as CGIAR research programs. Now they have called CGIAR research initiatives, which largely works on 5 themes. So all the activities which these 11 centers work on will be on these 5 themes: climate adaptation mitigation, environmental health and biodiversity, gender, nutrition, and poverty. Okay, so from isolation they have come together to work together. Okay, so that's the main idea. You have direct and indirect impact at individual farming system and at the national level. So we need to look at these these
maybe when we
perspectives,
have a discussion on measurement,
yeah.
you can come back on this.
I stop with this. See, when you look at the impact of CGR, if you look at 1970 to 1990s, it was largely more direct impact. Varieties, you have the germplasm collection, and then training of NAS scientists, capacity building, very direct impact. But then post 2000s, the type of interventions have become very complex. You have the release of variety continues, but then biofortification, impact on health, all these things. You have complex transformation pathways. It's not a single variety. It is variety plus natural resource management plus markets. So these combination characterize an intervention. So when you measure impact, more interventions on institutions, which is not there in the earlier period. Then again, there are more regulatory frameworks on environment and food safety, and approach also. They adopt what they call as systems thinking. You can't treat things in isolation. Landscape approach, focus on circular economy. And one important thing is when the CGI research program started, they did an exhaustive priority setting exercise, which was not there earlier. So you look at the economic surplus which is generated from each intervention, and then you decide whether to go for it. So that exercise was done from 93 onwards. I think I'll stop with this.
Yes.
Yeah.
Thank you very much. Thank you very much, and definitely we're going to share your slides with everybody in the team. But also, I think we have kept some time for discussion at the end. So, any specific questions or comments we want him to talk about, we can postpone that later. Okay, welcome back. For those online, we had a coffee break here. I hope you got something too. And we'll now move to our next speaker, Professor Pramod Kumar from ISEC, Institute of Social and Economic Change, our neighbor in Bangalore, and who has written a lot and done many projects on agricultural innovation in India. So we would like your insights today, but we'll be also coming to you again and again later on. Today is just the start of the program. And Gaurav and Amelia, we're running a bit late. So we can reschedule you earlier as per the original time if you wish, if that's better. Yeah. Okay, we'll do that. Pramod, over to you.
Good morning, everyone. Here physically as well as online present here, and I thank FGOSEC, ISI for giving me this opportunity. Well, my department in ISEC, ADRTC, Agriculture Development and Rural Transformation Center, is funded by Ministry of Agriculture and Farmers Welfare. So we mostly evaluate all their policy and programs. We are evaluating right now. We have done one field study on drone. I'll be speaking about that. We have done previously a lot of other government programs on whatever Ministry of Agriculture is running. Almost last 2 decades, we are engaged in this. So coming to the topic, I'm given 10 minutes, innovation in agriculture. It's a much wider area. So as you know, Indian agriculture, we say it is primitive basis subsistence farming. We have small size of holdings. Of course, our farmer is not that educated, but as far as use of innovations, our farmer is way ahead using all those innovations. If we speak the present innovation in agriculture, which starts from the Green Revolution days, when it was just considered that Indian farmer will not be able to adopt, but our farmer has shown how well advanced in thinking they are, and we brought in not only the food security in the country, but we have become the food exporter. Probably we are the largest rice exporter to US, and now our policymakers are thinking in this direction to move, given the whatever we have the now import duty which is being imposed from the US. So just what kind of innovations we are talking in India. I'll just name some of these because the time is short. We can talk later in the discussion. The one innovation which is very much in use is farm automation, drones. I will be speaking in detail. Then the blockchain, which is basically to track plant information. In coffee, we have seen blockchain is used in much advanced stage. We have now this blockchain coming in many other commodities as well. Then we have Internet of Things, IoT in agriculture. One of my students is working, doing PhD on precision farming. And one of the technique we are we are looking at is IoT, how it is helping the small farmer. Then GIS, my colleague in ADRTC, we are conducting a project on GIS, how it is helping in agriculture. We have taken spices. Last week, our team was in Chennai. So under GIS, there is one each product from the district, which is identified as a product of the district, and then we are trying to map how this GIS system is working there. Then we have AI, ML, artificial intelligence, machine learning. Again, it is being used for laser scanning and spectral imaging. We were talking about the satellite. I think satellite, along with the use of our drone, we can see the forecasting business of agriculture, which earlier our Patwari system was there, who gives us estimates of area production, and now machine learning and other things are coming up in a big way. Then controlled agriculture, controlled environment agriculture, greenhouse, glasshouse, all those are being used, although on experiment basis, using of hydroponic, aquaponic, aeroponic techniques. Precision agriculture, as I said, we are already in existence, and our farmer is working on it. Looking from the government side, I will just say 3-4 schemes which government is running, playing a role in automation and innovation. Farmer producer organization is the one program where we are trying to expand 10,000 farm producer organization was the target, which probably is already achieved, and we are moving forward.
Definitely. 10,000
Yeah.
definitely achieved.
Yeah. Through this, there are agri-tech companies which are working with FPO. Sumanati is one of the examples where they are providing to provide input and output to the farmers, directly to the farmers. Then the development of AgriStack. India is crafting a united database of agriculture data sets. Now this is again a government program. Then there is digital soil health cards. So soil health card was started. Now it is launched into digital soil health card to give a specific characteristics of the soil, which farmers, what kind of micro nutrient farmers should use to increase their productivity. Then there is direct benefit transfer of fertilizer sales. We did one study on point of sale, where the subsidy is given to the farmers based on actual use of subsidy of fertilizer. There is a point of sale machine like small, yeah. So at the retailer, the whatever farmer purchases, they have to give a thumb impression, and through that network, although we found not even 50% is yet through that network, but probably within a decade, we will have the control on the subsidy, which is just going half of the we say 50% of the subsidy, which is on the name of agriculture, in fertilizer is going to the industry. So we can stop that, and it can control basically direct use, how much fertilizer is directly being used. I think that also innovation will bring in more precise information. Then we have National Agriculture e-Nam market. Although it was started with a big fanfare, but some success. There are success stories. There are failure stories also. Through this program, government is bringing innovation. Then Agriculture Accelerator Fund and Digital Public Infrastructure is the Accelerator Fund is being created by the Government of India to give open source digital public infrastructure to raise the facilities to the farmers. So these are some of the basic programs which are towards innovation. Now, coming to innovations, if we see before 2013, in India, in the agriculture, we had less than 50 startups. Today, we have 1,000 startups already by 2020, and probably within last four years, there would be many more. Just to give you one example here, in the year 2022, there was $1.15 billion of total funding towards agri-tech, the venture capital which was created. The areas where this venture capital is being created is agri-tech, agriculture infotech, agriculture fintech,
Okay.
towards financing the agriculture, which like earlier, the small and marginal farmers generally they were at the hands of the trader, land money lenders and all that who charge 36, 40, 60, 70% also. In West Bengal, one of our study we found the interest rate exceeds 100%.
Yes.
So now these agri fintech are coming forward, where there is much better transparent system, and there are startups with providing the finance to the farmers, avoiding the intermediary. Then agriculture mechanization, automation. I have total. There are 114 deal which have been done in the year 2022, worth of $1.15 billion. So the areas are agri fintech, agriculture mechanization, automation, farm to fork brands, agriculture biotech, digital solution and precision agri-tech, end-to-end ecosystem, downstream agri-tech. Probably we can go into much detail, but given the time, as Madhuras asked me to speak about what we are doing in the field, I'll just
Give the drone example.
yeah, drone.
Yeah.
So there is a program which we are recently evaluating. There are Government of India scheme of launching 14,000 drones, and 500 drones have been distributed. This was in the last April. In November, they have asked us to do the evaluation program in September, October. We started the program in November. So these 500 drones have been distributed through what you call the self-help groups. It's a drone given to the women. Self-help group is run by the women. So one drone to one self-help group who will be lending this drone service to the farmers on nominal rate, whatever market rate they can. The machine is provided either by the government or by the agriculture, those fertilizer companies. Training is given by the fertilizer companies to drone. The self-help group, the person who is given the drone is called Drone Didi. This is Namo Drone Didi program. So drone is given to the SHG self-help group. Then one of the drone Didi who takes the drone, she gets the training either in the big city or in the state capital, sometimes in the smaller city also. So these drone DDs are called there for 20 days. All expenses are covered by the company. They are provided transportation, food, living, everything. So 15 to 20 days training has been given at the first step, and then drone is taken to the field, and then round of uh, uh, information, uh, hand-on information is given in the field. So what we have found, recently we had conducted one workshop to evaluate the program, where we call the fertilizer companies, drone DBs, all the stakeholders. There we found the government asked for 500, but the fertilizer companies have given additional 500, which is not covered in our evaluation, but they are asking us to also take that into account. Why? Because there is so much demand that fertilizer companies think that they have to move forward, and probably this is very innovative. On the ground, what we found at the beginning stage, farmers are much interested, and they are saving every acre. They are saving 3,000, 4,000 rupees. And drone is being used basically at present liquid fertilizer. Some places pesticide also. But there are many other activities which can be brought in under the drone, even scanning the soil and scanning moisture, and they have to put other scanners into the drone. So farmers side, they are very much interested, and they have come forward. They want this service. The problem which drone DDs and from the distribution side we see, because at the initial stage they are not well trained. So running the drone, sometimes drone falls down, it will hurt. Either there is damage to the drone, or sometimes hurt to the drone DD who is running it. So a lot of logistics is being worked out. We are still providing through our workshop. We are providing our inputs how they can be better enabled, and then launch. It's a starting of 500, so it has to be 14,000 to be distributed. So this is, I think, one big program which is coming up in next 2 to 3 years. We will have much higher number of drones in the field, and it will cover much higher area also. The precision farming, where we started with many different areas like drip and sprinkler irrigation, which is much in use. So we wanted to bring in some more innovative aspects of the precision farming. So we ultimately we've seen the sensors which are installed in on the field, where the sensor is providing information about moisture, about weather, fertilizer, irrigation, how much water is to be given. It will give you exact information. This much is the water, how much is required, what is the moisture in the air, what is moisture in your field. All information it is giving, and we find 30 to 40% saving irrigation alone.
Is it a government scheme or is it your ministry?
No, it's all private.
Okay.
It's a private firms who have installed the sensors, and they are charging. Even they are struggling. Initially, they were finding that farmers not coming forward. Rate was high, and gradually it's becoming successful. And as it expands, there will be many more such sensors are being installed. And it started with grapes, soybean. Now there are other crops also coming. I think there's a lot of feedback we can
Discuss.
discuss.
Yeah, thank you. No,
looking
I'm worried
forward to your
about our.
project.
Thank you, and I think we have a lot of questions. Hopefully, discussion of that type of question, even over lunch, we can have. So I would, since we're running a bit late here, we can have the introduction to the project by Sandeepan, or if Gaurav, you and Emilia would like to go first, we can do that, because I know time is important for you.
Look, happy to do it either way, whatever you suggest. I'm fine. About Amelia,
Okay.
what suits you?
Yeah, your introduction, Sandeepan, is not that long, right? That's fine.
No,
We can do after the introduction. I
And
think that
it'll
makes
be
more sense. Yeah.
Sandeepan, Dr. Sandeepan, I ask you now to give the introduction to the project. Yeah. And you will be very strict to time. You're not a professor, so I'll have to keep you under. Can you make it? Huh? No,
Is the
but
screen
it's,
is the screen visible to those online?
yeah.
Yes, it is.
Okay, so okay, so as Professor Madhura suggested, I'll really go quickly over my presentation. I'm Sandeepan. I'm a co-PI in this project, and I work in the capacity of director at the Foundation for Agrarian Studies. Maybe by way of a distinction that somewhat makes me unique is the fact that I have the privilege of having interviewed Professor M.S. Swaminathan and Professor Gurdev Kush as part of a project that I handled. So yeah, so that's by way of my introduction. Now maybe a couple of lines about the organization that I represent, Foundation for Agrarian Studies. You can see the logo over there. It's a research organization working in the field and trying to study the changing social and economic characteristics of rural India, but also other developing countries for more than 20 years now. We have a unique program called the Project on Agrarian Relations in India, which is a village studies program under which we, the whole team of the Foundation for Agrarian Studies, we go to villages, we spend considerable time in the villages trying to understand the not just the conditions of the village, but also within the village how the Indian countryside is differentiated along the lines of caste, class, and gender. So this is something that makes us unique. We have surveyed, our surveys span across 12 states in the country. And we have also, based on this data and other studies, we have also taken up a lot of thematic work. For instance, what is the state of small farm economy? What is the state of women farmers in India? How did the pandemic affect different categories of the cultivators, the farming population? So yes, and there is a lot more themes that we have covered. We also bring out a journal called the Review of Agrarian Studies, and it's a well recognized journal of international repute. So I would request this audience, if they have not seen the journal, you can visit the journal at ras.org.in. Now, one of the themes that we at FAS have more recently been very interested in is on the question of science, technology, and in the interface between science and technology and agrarian societies. And this project, I'm very, this came at a time when we were exploring this particular, this interface. And I'll just take two examples to, and we have been doing a lot of work in this direction, trying to bring together a group of agricultural scientists who are well concerned about the about our farmers, about agricultural development, agricultural advancement, as well as those who are looking at it from the social science perspective. And when we were trying to do that, we realized that often these two sects, these two groups don't interact with each other, and there is a big gap. And FAS has, for the last more than half a decade, has been trying to develop a platform where these two players come together, they interact. And I'll take a couple of examples how this interaction is still missing. Taking cue from what my what the speakers who spoke before me today. One was this example of cheating, farmers cheating using the insurance, the different technologies and tools that are being used to sort of see if what is the the accuracy of the insurance programs. So there is one section which would see that there is only 60 to 70% accuracy, and therefore which is leading to cheating. So this is one way of looking at it. But when you look and discuss with, as social scientists, when you go and discuss with farmers, it is another perspective where completely on the other side, the perspective would be that it is only 60 to 70% accuracy, and therefore actually we are not getting the appropriate insurance. So I am trying to say that these are all examples, and such examples run galore. I was yeah. So yes, so this is a dichotomy. When we were this as part of this project, we went to ICRISAT again. There we saw that we inside the campus, and as we were, I was listening to Dr. Pramod.
Is it moving? No.
Yeah,
Not yet. He has not
I'll
come to the
know.
PPT yet.
Yes, we'll just a lot of what I wanted to cover in the PPT has already been covered by Dr.
Okay.
Surajit, so he
Okay.
has made my life easy. So, but a lot of what we saw in ICRISAT, and it was the ICRISAT campus that we had visited recently, we saw these technologies being at use on the ground. And then we also happened to, some of us happened to visit various villages in Andhra Pradesh and in Telangana, where we say that none of these technologies are actually at use, or even if they are being used, it is only a very small section of farming population that is using it. So there is a clear dichotomy which we see, which I'm talking about, between those who are studying agriculture science and innovation, and those who are practicing it, and those who are looking at it from a social science perspective. And we have been trying to bring this gap, bridge this gap, and this project perhaps is a step in that direction. Now, the project, as the name suggests, tries to look at at a very broad level, what has been the reach, the level of adoption, and the impact of CG innovations in India. CG innovations in India, and let's go to the next slide. So we have already heard in detail about the CGIAR system. Maybe a word about SPIA. SPIA is the Standing Panel on Impact Assessment. It's as the slide says, it's an impartial panel which has been trying to study the reach and the reach at level of adoption and the impact of CG research. There are three major heads of work that the SPIA program consists of. The first is country studies, and then there are the others, causal impact assessments and use of rigorous evidence. And it is in the first head, country studies, where this project falls into. So this is part of a country study of SPIA. Yeah, let's move on. The aim, as I said, and this will keep coming back in this presentation and in the presentation of our team, it is about trying to understand the reach, the level of adoption, and the impact. Now, there are a certain group of has been defined by the CG system as high priority countries. We'll look at the map in the next slide, and it is in these countries that these studies are being attempted. Go back to yeah, okay, go to the next slide. Okay, so this it's a map which we would have done better by scanning it, a little more, zooming it in. But nevertheless, there are phase 1 countries where there are 4 such countries, which is Uganda, Ethiopia, Vietnam, and Bangladesh, where these studies have already been conducted, and the report is at an advanced stage. We'll see them very soon. Phase 2 countries and phase 3 countries. Phase 2 countries, are North India, although their map wrongly depicts it, on the eastern part of it. It will be North India, and phase 3 country is South India falls in it. If you go back to the previous slide, phase 2 countries are where all the 3 stages of the studies will have to be conducted. Stocktake will come to that, but all the 3 phases have to be conducted. Whereas phase 3 countries are only the first 2 stages of the study will be conducted. Now, let's move on. So, yeah, there is no need, because we have already deliberated upon. Just one thing, that of 11 of about 15 CG institutions are actively working, and it has been actively working for a very long time, which gives us a sense of the range of innovations that they have already been brought about, which also means that the scale of the project is quite big. Now, if we go to the North India project, yeah. So, as I said, this project that is the phase 2 project. It's a phase 2 country, although it's not. It's only part of the our country, which is North India. Here we are going to do. Mute yourself. Yeah. Okay. Yeah. Okay. So this is where we are going to all the 3 components, and these are the states that we are going to look at. 6 states in North India: Punjab, Haryana, UP, Bihar, West Bengal, and Odisha, where there are 7 agroclimatic zones that we will span through. And all the 3 components that are part of these country studies will be conducted, and there is a 4th component, and we'll talk a little bit about each of these components going further. But there is a 4th component, which is gathering qualitative information by going to these villages some of the villages that FAS has already studied as part of its village studies program, and gathering specific information from women farmer groups and KVK. So this is a unique sort of contribution that we are bringing to this project. That has not been part of the other phase 1 countries that have already been studied by as part of country studies. This is again a repetition. There is no need to spend any time on this slide. We have there are 3 questions. What is the reach of all CG innovations? What is the level of adoption? Whether this level of adoption itself is changing, whether there are those who have adopted but are now giving up, whether there are regions where the adoption levels are very low. And third is, what has been the impact at different scales, impact on individuals, households, impact on agri-food systems and the environment. Yeah. South India study is the phase 3 study, which is, as I said, it has only the first 2 components of the India study, which is stock take and stakeholder consultation. Both will be part of it. The 3rd component will not be taken up for these South India studies. However, the idea is that the eventual output of that we will arrive at would lay the ground for the socioeconomic surveys and other data collection at a later stage. The states that we are considering are, we can see that these are the states that we are looking at. Okay. Now, go to the next one. Yeah, this is the only slide where I'll take a few minutes.
Just a couple of minutes to.
Yeah. This is the only slide and the work plan. Yeah, and then our team will take up. So now I have been saying that these are some themes, keywords that I've been using throughout my presentation. One is stock take. So what is this idea of stock take is, and this is for a span of 20 years from 2000 to, not now, but maybe 2022, 23. So these 20 years, all the CG institutions combined, which are operating in India, to come up with a long list systematically documenting all their efforts which are reaching some users and end user, not in internal research effort, but efforts that are reaching an end user. Trying to make a systematic document of that is the process of stock take. And the output of this process is what we call a long list of innovations. Once this but when we are talking about innovation, there is a very strict definition of innovation. That is, again, you can read it up. But the idea is any technology or approach where there is a CGIAR input. It need not be that CGIAR institution is wholly responsible for it, but any input from CGIAR inputs have gone. That again gives us the idea of the scale that we have to cover, and find also policy contributions, which are institutional interventions. Now go next. Yeah, don't go. This is your. Just go to the planning, work plan. Yes. So the stock taking process is what are there the three main components, which is basically going through systematically the literature, both grey and published literature, visiting scientists, and working, consulting with the partners at the NARIS system, as well as state agriculture universities, coming up with a long list of innovations. Once we have this long list of innovations, the idea is to then present it in a workshop, and here to arrive at three major questions. One, what is the scale of innovation in the sense of, in terms of states, regions, households that have been affected, users that have been affected by it, and what is an observable feature that can be measured. That would, the idea is to come up with a list of major innovations and not all innovations, which will be considered as the short list. Once the short list is arrived at, then we jump to the next component, which is trying to gather information through socio-economic surveys, as well as collection of biophysical or any other kind of data that can help us measure the reach and then the impact of this innovation. So this will be the second major output of the project. So and then of course analysis and report writing, which will be going through in the 3 years. We have already started the stock taking, and my colleague Tapas will take some time to take you through what has been the process of stock taking.
Thank you. And I think, Sandeepan, this fits in very well with, we will have our two colleagues from Monash speak about the very important phase, which is, once we have the stock take and the innovations, what are the methods we are going to use to study GIS and soil sample, DNA fingerprinting, etc. So what are the innovative approaches? So we will have Gaurav, will you be starting? Or you and Amelia? The floor is yours. Yeah.
Okay, no, thank you. I'll make a start, and then Amelia will take over, if that's all right. I just, first of all, just wanted to quickly thank you, Madhura and Sandeepan and Tapas in particular, for organizing this event. I mean, it is the official launch of our project, and appropriately, it's happening in Bangalore and not in Melbourne, where I'm based. So that's good. And also thanks to the previous presentations. I mean, I think they were very, very useful for me. I've been taking copious notes, although I know the slides will be available later. But it's been very, very helpful already in terms of, I mean, there are people in this room who have a lot of experience in this area, and there's much to learn from them. And I've already got a bit of a taste of it this morning, afternoon here, though. So I'm just going to, firstly, let me just try and share my screen. Whenever I actually, I always have trouble, so bear with me. So you can probably see my screen.
Yes.
Yeah. So what I'll do is I'll just make it a little bit bigger. I've tried using but sometimes it doesn't work when I try to. So if you can see it, I'll just make it a bit bigger. Is that good?
Yeah, yes.
Yeah. So, okay, so, I'm going to be fairly brief. I'm also conscious of the time limit. So, and I'm just going to begin with just some remarks, which will probably be very general. And, but let me just begin anyway. So, and then Amelia can actually elaborate on more specific, a little bit more specific things. So, impact, I should make it a bit smaller so I don't cut it off. So broadly speaking, one could, I mean, this is not rocket science, it's very common sense sort of idea on this slide, that the causal chain, if you like, from innovation to impact, essentially 3 or 4 steps in that. You begin with the innovation, which may be new technology, new practice, or even in new institutional arrangements, etc. With that innovation, the next step is really getting the end users access, I mean, to that innovation, which farmers in our case, and that may depend on a number of different factors: information, resources available to the farmer, and there could be many bottlenecks to access, which are really important to understand. That's one area where, like Sandeepan talked about, the social science perspective is actually important. From access to access doesn't mean adoption. So there is the next step is really how much of it is taken up. And there again, there can be constraints between access doesn't guarantee adoption. So there may be further constraints to adoption of various kinds. And also we need a verifiable measure of adoption, which is actually quite important. And then finally, once there is some adoption, then it's meaningful to ask the question of impact, which is in terms of some measurable outcomes. I mean, in the cropping context, it could be crop yields, or it could be income. And in fact, I mean, I think that's, excuse me, that's an important, the choice of the outcome variable is actually relatively an important one, because depending upon the outcome, the impact could be different. I mean, increasing yields does not necessarily translate into increased income for farmers if the technology is very costly, for example. And a key point in all these 4 steps is that accurate measurement is key. It's very important at every stage. There's the old saying, garbage in, garbage out. In a way, it's a kind of way of only good data will lead to good impact evaluation. So it cannot be overemphasized, the importance of that. Identifying causal impact in the context of agricultural innovations, one very obvious point to make is causal impact is not correlation between outcomes and inputs. So and that's an obvious point to make, but important one, and it's the starting point really in terms of thinking about impact evaluation. And once you pose the question in terms of something more than just a correlation, then actually identifying causal impact is a pretty demanding exercise. The overall, I mean, when you're talking about causal impact of agricultural innovations, broadly, it's part of the overall enterprise, if you like, of impact evaluation of any intervention. So in some sense, the methodology for evaluating impact of any intervention is relevant also in the context of agricultural innovations. And on that, the IE methods, the impact evaluation methods, there's a huge and still growing literature on both the methods and, of course, a very, very large number of applications of different methods. And but the starting point is data. So I'm just going to briefly talk about 3 main types of data for impact evaluation. So these are broad categories. I mean, there's what is called observational data, which may be data that comes from surveys. It may come from administrative data sources, and of course, increasingly now also remote sensing data from various sources. So that's observational data. Then the other category of data is what may be called experimental data. That's based on field experiments actually done in the field and implemented in the field. And the third, which Sandipan also talked about, is the qualitative data, which may be based on things like key informant interviews, focus group discussions, village case studies, for example, and the like. So the key point is that one should, in my view, and I think perhaps a view shared by many others, that we should think of these different data sources as complementary, rather than choosing between one or the other. I think they can illuminate different aspects of observable impact, and the other key point is that the impact evaluation methods are differ depending upon what data you're going to be using. So I'll just stop here. It's a very general kind of introduction to impact evaluation methods, and I'll let Amelia take over from this point. So thank you very much. I'll stop sharing my...
And over to Amelia.
Thank you so much. And thanks everyone. As I'm, let's see, slideshow. Hopefully there. Can you all see that?
Yes.
No, it's a blank, not yet.
Oh, it's now you can see it?
Yes.
Okay, perfect. So thanks everyone for being here, and I've already learned a lot from the various speakers, so I look forward to continuing learning. As you already know, my name is Amelia. I'm at Monash, although not for long. In May, I'll actually be joining Macquarie University as an associate professor, but for now I'm at Monash, so I've got the Monash theme PPT. Without further ado, I'll talk a little bit more about impact evaluation. And I revised my slides just a little bit based on what Madhura just said. But I first want to spend just a minute on the why of impact evaluation. Why should we evaluate impact? And one key reason, of course, is to inform policy. So generating rigorous evidence can help policymakers have access to better evidence and make better decisions. It can also help us understand what works and what doesn't work once we're off for sort of an ag field trial, right? What works when we're actually in a farmer's field? This relates a little bit to what Sandeepan was saying as well. And finally, in the context of our project, what we're really looking to do is to understand the return on investment in CG system agricultural innovations, right? And to understand the return on investment, we have to understand impact. And so I'm going to just spend a little bit of time making sure we're all on the same page about what we mean by impact. And this is increasing the evidence that donors want to get before they're willing to continue investing in systems and in programs. So what do we mean by evaluation and what do we mean by impact? When we talk about evaluation, as economists, we mean something different from sort of M&E and process evaluations, right? Process evaluations and M&E tend to answer the question, what would happen, are programs and interventions being implemented effectively and well, right? And this is very important. It helps us understand, what works and what doesn't in terms of implementing programs, but it doesn't necessarily tell us whether an innovation changed lives. Did it improve a farmer's livelihoods? And that's what we are looking to do and looking to understand at the end of the day with this program in the longer term. So take one potential research question, right? Did a new wheat variety result in better yields for smallholders? Now, as previous presenters have mentioned, a lot of the CG system innovations are much more complex than this, right? So we may be looking at natural resource management processes or even policies, and things get even more complicated, but let's take a simple question for now. So did a new wheat variety that was introduced result in better yields or incomes for smallholders? Did the innovation impact the outcome that we care about in the population of interest? And if yes, we want to understand the magnitude. If we want to look at return on investment or do cost-benefit analyses, then we really need to understand this magnitude as well. We need to have a precise number on the effect. And so to do that, the crux of the matter is really what we call a counterfactual, right? So it's what would have happened in the absence of the innovation. What yields would the farmer have received had they not used a new wheat variety? So we want to compare the outcome with the innovation to the outcome at the same point in time, the same season, the same rainfall, the same everything for the same person had the intervention not been available. Now, of course, this last scenario is theoretical, right? It's conceptual, it doesn't exist. We can't observe the same farmer in these two scenarios, but that's sort of the conceptual item that we would like to have access to. So we call this a counterfactual. It's just a shorthand, but it's a state of the world that program participants or users of an innovation would have had if the innovation didn't exist or the program wasn't implemented. We can't observe this, but we try to mimic it. And these are the kinds of methods that Gaurav was mentioning. We try to mimic a counterfactual by using some kind of comparison group that is similar to program participants or users of an innovation. There are different ways of establishing a counterfactual with econometrics and other techniques. And I'll just go over them very briefly. And we're going to use a mix of these. So they're experimental methods, as Gaurav mentioned. So these are usually implemented through randomized control trials. So this is where you may randomly assign some farmers to control and treatment groups, or you may randomly encourage some farmers to use an innovation, or you may provide some farmers with information about an innovation. This is a type of design that I've used in previous studies. But the idea is that because you're selecting them in a in a random way, the groups are very similar in the absence of the innovation. They haven't selected into being users, therefore you can pretty reliably attribute any changes in their outcomes to the innovation or program that you're evaluating. Then there are quasi-experimental methods, which are econometric ways of trying to get close to a randomized controlled trial without actually randomizing everything. And so you can use difference in differences. Of course, it's beyond the scope of this presentation to go into a lot of detail, but these are non-experimental ways of approaching experimental methods. You can use matching, which is a fancy statistical approach to generating treatment and control groups that look similar on observable characteristics. And then you can use panel data, which is observing the same farmers over time and seeing, some of them switch in and out of using an innovation and comparing their yields or their incomes over time. And because you're tracking the same people over time, you're able to kind of filter out some of the time invariant characteristics. So, for example, if you're observing higher ability farmers, you're comparing them to themselves over time. And so that ability gets it's sort of partialed out, as it were. Then there are mixed methods, which we are going to use as well. And they don't necessarily establish counterfactuals. They don't help us understand what would have happened in the absence of innovation per se, but they can help us strengthen the validity and interpretation of these counterfactual-based methods. And so it really helps you combine the sort of rigor of the quantitative approaches with a more the depth of qualitative insights. And so it can really help provide a more complete picture of impact and adoption dynamics. And so the kind of methodological innovations that we're hoping to include in this project are many, and again, way beyond the scope of a short presentation, but some of the ways that we hope to really innovate in both measuring impact, measuring outcomes, and hopefully estimating impacts is by combining these impact evaluation methods and household surveys, representative household surveys of different agri-ecological zones with DNA fingerprinting. And this will help us better identify, what varieties, what types of crop varieties are farmers actually using in their fields, because sometimes, and at least in other countries, researchers have found that farmers may purchase a variety, they may misremember what variety they're using, or the variety, so sometimes there can be issues in the breeding system, et cetera, and in the seed system that mean that what farmers think they're planting isn't actually exactly the same variety that they're planting. So anyway, this is one way that we hope to complement our household surveys to actually figure out the spread of CG crop materials. We're also going to combine household surveys with remote sensing approaches to be able to sort of extrapolate beyond the exact areas that we're collecting household data. And we'll be trialing a lot of different measurement approaches with sort of small scale experiments that are built into the larger household surveys. And this is the slide that I made last minute because I realized that this was what Mother actually wanted us to spend more time on, not so much on the econometrics, but here we are, happy to answer any questions, because this is really where the meat of the work will be. So with that, I'll pass it back to you in the room, and happy to answer any questions as well.
Thank you, Amelia. You managed to, cover a range of, I think both you and Gaurav, range of the methods and approaches. And I think what I would just suggest, of course, we will collect questions and comments for you if you can't stay on for another half an hour. But what I think is the next workshop perhaps we need to have is more based on stock taking and the kind of, we already have a kind of long list, at least examples of innovations in India. What are the methods that would be suitable to? So let's plan on that. Now I will come back to this room and hand over to Dr. Tapash Modak, who is going to be who's the kind of the project manager for this whole CGIAR-SPIA project in India. And he's going to just tell us a little bit about the stock-taking exercise, which draws on what the CGIAR-SPIA framework is, but what we have learned from it in the last few weeks and months. And Tapash, if you can briefly introduce your team before you start.
Thank you, Professor Madhura. Let me, okay, the first thing that it's already 12:25 and try to finish by in 15 minutes that will get enough time to discuss.
Yeah,
because
you-
that's
you
the
go
stage
ahead.
that we are
Yeah.
looking for the comments from the expert. So, yeah.
Can they hear us?
So now at the project team, we have a Dr. Hassan P.K., he's a climate expert, and we have also Ajil, he's our research officer. We all have Sai Chandan Kotu, he's a senior research assistant. We have Daya Thomas, he's a research assistant. And in online, we have a Christy Saikia, she will be joining us soon from the this Monday, next Monday. But I'll try to see with this forum that we are looking for a person from the agriculture science background. If any of you have any recommendation, please let us know. We're seriously looking for some in this team. Okay. Now let's come to the specific to the presentations. In this in this part of the presentation, what I'll try to explain that the in details the first component of the project, which is the stock take process, and we are currently working on this. And I also try to Madhura explain that I'll try to explain our lessons from the recent work on ICRISET. Recently completed the preliminary desk work and also visited their headquarters in Hyderabad. Okay. Now, this has been explained by Sandeepan. I'm not going to details, going to the details. In this stock take process, there's a two-step. First, that creating a long list. And the main questions was you're looking for here, what has been the extent of CGI research activity in India over the last 2 decades? So it will give us like a long list of the innovations by the each CGI research center in the last 2 decades. And to get it, how to do it, there's a two main approach here. First, the desk research. And you can see there's a large number of source of information which are going to exercise here. Either it's a publication, real literature, CGR has its own dashboard result, and they also have a separate impact evaluations report. There's a dashboard for there. And along with the government policy, the administrative data. Also, we'll also be planning to do review the CGIAR social media handles. The second part, the aspect of this for this step, the interview and in-person meeting with the scientists from the CGIAR centers. As you know that when it's come to the CGIAR innovations, it's when they very closely work with the ICAR and the NARIS systems and also the State Agriculture University. We're also planning to meet the scientists from all these institutions. Next. Okay. Now it's come to the again. I'm not going to repeat, but from the long list we will come to the short list, and here the criteria would be based on that what have a diffuse at a scale. I'll come detailed discussion on how you think what would be the appropriate scale when we are talking of certain innovation. And the second important is which will have a distinctive observable features. I'll give this discuss these details with the example of our requisite visit with then also some specific innovations. The main question what we look here that has this innovation like to reach the farmer at a scale or not. And again, this will be done based on the consultation workshop with the CGR and NARIS partner. Okay, now let's come to the next. So, element of the stock take. What is the final output of the stock take exercise? Would be you can see it's like a spreadsheet which will contain the detail of each innovations and the policy contributions related to the CG work within a country. And you can see the just main 7 header here. This is as per the guidebook on developed by the SPIA Global Advisory Team. And this is the standard kind of format. And we again will seek your opinion how to incorporate it in the Indian context. Let me give you a little bit in details about each. What do you mean by each header here? First, the innovations, the name of the innovations. Second, CGIAR related efforts and development. What are the major, the role of CGIAR, either it's input or in the development, either in their own research, what the CGIAR centers play a role. Then the brief about the features of the innovations. What are the, it's like, what is the major nature of the innovation? Fourth is, I told it's important, the details of the specific features are the identifiable characteristic of the innovation that can be distinct it from the other technology or practice. Let give me a simple example like there's a variety, it's called stress tolerance rice variety. It's a flood tolerant. It's like a sub-1 gene we can told. If we want to understand what are the objectable features for this specific innovation, that could be one, that farmers showing rice varieties with sub-1 gene. That could be the one, and the method could be different. Like that, I'm not going to discuss here. But if you want to capture this, the gene, the variety, this we have to get that how many farmers are showing these varieties. The method could be the household survey or the DNA fingerprint, or in a picture, the lip. That could be a different method.
One,
Yeah.
Sub-1 is submergence tolerance.
Yeah.
Just for
Yeah. Second, the phenotypic characteristic such as the color of the husk or height of the plant. For instance, the Sarna sub-1 has a white husk color and a semi-tall plant height of the around, which is around 100 centimeters. This is the specific features of the innovations or the variety. And as Madhur said, it's a tolerant to the summers. They can sustain at even the underwater at least for the 15 days. They can give the similar kind of yield even after the be under the water for 15 days for a time. And again, that could be the measurement unit could be different, but that is not the scope of now. We're exploring on that thing that will come under the next stage. Second, only one, the location of the CGIAR activities. These all will come from our Braille literature or the discussion with the scientists. What are the specific innovation are located or more likely to find the adoption of this specific innovation. And third is the evidence of adoption. You know, the many independently the CGIAR research institutes or the researchers themselves also conducted a lot of studies to review this kind of innovation. From our literature review, we'll try to find out what are the kind of current adoption estimates for different innovation if there is any study. Next. Now, I'll be a little bit try to explain what we gather from our research experience, and I also would like to get your opinion either we're on the right track or there's a need some kind of a because we are going to follow the similar exercise for the other research center. Now, stop the step one. The first is the desk research. What we found that the the website is a very useful to start with the website to review the website because it gives us a kind of a get the history of its establishment, also to identify what are the major research themes for the under the different each research centers. Who are the leaders who is taking forward the different innovations, the major focused area in India. So this is the first step we started with when we started education work. Second important source is the annual report. What we gathered from the last more than 20 years, we analyzed very systematic way where we got the what are the and you know it also give us like trajectory of the different innovation different time point. So that we gather from the annual report. Second, third is the thematic flyers because you see the EQSET, for example, they have a 3 major research program, and under them there's a lot of flyers are available in their website, and which is highlights their major work, major innovations, major focus area. That is another major source. And fourth is the newsletter and news links because any kinds of kind of a publicity comes, it comes under the newsletter and news links. And after exercising this whole work at desk at FAS, we come out a preliminary list of the explicit innovation. Here, the list is only the list of the innovation, not any other much details. Along with this list, we then again we plan for a visit to EQSET office to the second step, which is the interview and the in-person meeting. First, we had a discussion with the leadership and to get an overview of the organizations, what are the major focus area. Then we had a meeting with the heads of the 3 research programs, as I mentioned, mostly focused on the crop improvement, the resilient farm and food practice, and the policy perspective. And each this research program, they have a 5 or 6 cluster programs. And we also had an opportunity to interview with each cluster leaders and scientists from each research program. And we got a lot of gathered relevant publications, their impact assessments report and flyers. And I'll say also this ICTSAT has an open access library, which is also help us to gather a lot of information from this discussion, which they were referring while in our interview. The major output from this stage, what we got in the we tried that from our list, we could identify the missing innovations which is listed down during our desk work. And second thing, which is also found is very interesting, that we could categorize this innovation in different theme. Like I'll give you an example, like a seed. From the desk work, we come up with like a more than 250 seed variety. And we didn't have any clue. Again, the point is we don't have any agriculture scientists in our team. That's the one of this thing. And what we're thinking, how to seize this 250 seed variety? Is it each specific innovations or there are some category? And we could have an opportunity to speak with a senior seed scientist in ICTSAT. He come up with a kind of a major broad, bring some kind of idea that what is the meaning of this 250 variety. And we understand that no, there are, if we see this number of varieties, and it falls under 5 or 6 major innovation. Either it's a biphytobate pulp millet, or it's a stress tolerant, or it's a hybrid program. Okay. So this stage help us to develop this categorization again. Yeah. Now now in this stage we come back to the FAS, and now our focus is more on the innovation specific, not longer more on the like how we started the work. And from our information what we gathered, we'll be now working on the review all the based on the each innovation specific to understand the other headers like either description, observable features for the measurement unit that we're going to fill. And this exercise will help us to understand that observable features, scale and location, and even if they have impact. And while consulting during the visit, we also had a kind of a talk that if still there's some gap persist, we'll have a further opportunity to consultation with the concerned scientists. So these are the, I can say, if you're going to implement, this is the first step for the each CG centers for the stock tech activity. Now let's come to the how you see what we have done, that we take 3 major some innovation which quickly we can work on, and we try to feel how it looks like in the format. Okay, it's a Plantix app. I'll not go to the details, but it will come up like you can see the final output will be like similar. We have some blank here. You can see for the measurement technique, which we have not come up with on that stage. But it's a smart-based and AI-based technology application which help the farmers to get the necessary crop management advice. It has been promoted, led by the ICTSAT, and you can see there's a lot of non-CG partners. Either it's the agri-tech company or it's the Department of Agriculture, like the ICAR or NARIS systems. They're the partner, and you can see that the efforts also I mentioned details. And you see the observable features which we found that could be useful for this particular innovation. If we can get the information, the farmers install the application on their smartphone and upload the picture of that plant damage. Secondly, the Plantix can track the geolocated submission. And from literature, we found that this application has been used by 8.6 million farmers. No, sorry, it's received 8.6 million geolocated submission from across the India. Our major focus is mostly in South India and sorry, Andhra Pradesh, Telangana, Maharashtra, Punjab, Madhya Pradesh, UP, and Haryana. Next.
Just one minute. Any app can be downloaded, na? That observable feature.
That's not downloaded. Saying the app submitted 8.6 million.
No. Farmers install the app on their smartphone.
Submission form.
The submission is
chance കുറവാ.
1 minute.
കണ്ണൂരിലോ പോയി സമ്മതിക്കും.
You would not download, you take picture and then you upload.
Yeah.
So maybe that's a question.
Yeah, so submission is observable feature.
It can be so yeah, but
Yeah.
The purpose here is to give
How to measure app.
yes, the app company also will be having that is.
Yeah, please go ahead.
Yeah.
Sorry, sir.
It's in share mode.
Next slide.
Next is again that it's a soil health management one program schemes. It's the government of Karnataka in collaboration with Agri initiated. It's called Bhu Chetna. Many of you know, with a aim for to enhance the yield level of major dryland crop, and later it's expanded in other states like Odisha, Andhra Pradesh, and Telangana. And the Karnataka started with Karnataka, yeah, Bhu Chetna, and the
Okay, keep
sorry.
going.
Okay.
You can see this.
So the main partner is again the State Department of Agriculture, the State Watershed Development Department, and the SAUs, the State Agriculture University. You can see that the description. I'm not going to say discuss details, but it started in 2009, and they saw it's a good success. And initially, the idea was for only for the rain-fed areas, and then later it's also expanded to the irrigated regions as well. And it will aims to generate the taluk-wise fertilizer recommendation rather than the aggregate for the state level. They also claim from the literature it's come that in Karnataka this intervention reached around 26,000 villages covering 4.2 million farmers, and a total 92,860 soil samples were analyzed from the 30 districts in the state. This is all we could gather from the whole review of literature. The next on the seed variety, I already discussed. It's a stress tolerant rice varieties for the flat tolerant sub-1 gene. It's developed by ERI in partner with the ICAR National Research National Rice Research Institute, and there's efforts that CGIAR major it's come under the STASA project with scientists from the US Davis. They together worked on to develop this variety, and the claim that it has like a 9 to 12% of the India's rice area and 30% area in Odisha is under this variety. And the jointly ICAR NRI and ERI jointly developed the Sharna Sawan. And I already explained the observable features. I'm not going to take, but it's particularly the location what we found that it's mostly focused in eastern India, which is more flood prone, particularly in the Odisha. Yeah. So I'll next. Okay, this will be look like our final output. Now, from this audience, what I try to we're seeking the questions for the discussion in the next couple of in the next the part of our session. We have three major questions. Are these row headers are exhaustive in the stock take spreadsheet, or you have there's any gaps which you suggest? Second, it may be useful for the next our level when you're going to plan for the household survey. What can be the appropriate scale for the different type of innovation in India? You know that one set of rules cannot be applicable for the different innovation. How you look the seed variety that may be different from when it's come to the kind of extension services or kind of when you look to any kind of a natural resource management. So that we would like to understand from your expertise. Third, do you also think from your experience, there's any kind of suggestion that novel measurement techniques for the different types of innovation, particularly under these three themes on the seed variety, second is the extension services, or the natural resource management? Yeah. So I'll end with this. Thank you.
Pass the mic back to the thank you very much, Tapash. I know there's a lot of work which you've just tried to summarize in a few slides, and those three last slides we may call up later in the discussion because that was the interesting part. So now the floor is open for discussion, and we can go around the room or anybody online or offline. Dr. Achot, would you like to say something? Please, can you pass him the mic?
The project is a very interesting project, and you've done a lot of groundwork. My only suggestion, because I've retired about 10 years back, so I may be a little outdated. My suggestions will be outdated. But I'm just associated with one project with the Indian Institute of Science, Department of Automation. Dr. Narari heads it. So he says the kind of information you're going to collect over such a long period of time, processing that data is going to be very tough. So what they suggest is you should go for those large language models. Then it becomes interactive. All you have to do is just give the data, give some impact variables. It will itself categorize it using ChatGPT and all that. And then it will start interacting with you. So any question you ask, you'll get a ready-made solution. So I think that would be one suggestion which I'd like. Another thing is And also, when you do this review of all these technologies, please also see what are the lacunae, so they can revert back to the scientist and they can try to improve it if it's possible. Because there's so much of work that's going into it. So, but I basically feel with Indian Institute of Science, with their help, you can get into the large language models. I don't know much about it, but I've just seen him doing it. But it's very impressive. It's, I believe, it's not very tough. They can take it up as projects and they work very fast. Dr. Narahari Rao is a scientist at the Indian Department of Data, DAS, I think. Yeah. So very, very nice person.
He just retired.
He just retired, but he's still working. So he's still working.
Retired last
Yeah.
July.
Yes. No, but he's working. He's working till 70 until 2028. They've extended his term. A very, very eminent person. You could get that. That's
Thank you very much, Dr. Joseph. What I want to say here is also that we call on people like you because you see, we have been asked to look at innovations from the last 20 years. And many of the scientists, whether in NAS or in the CV institutes, who were part of innovations in the 2000s or 2010s have retired. So we would like, any other names of people also.
Definitely.
Interacting with you, Dr. Pratyushya, we wanted to call him traveling. People who've been in the NARS system in the last 2 decades, and that would really help us move forward. Thank you so much. It's very useful information. Yes, Vilas, yes.
Thank you, madam, for giving the opportunity. And I have associated almost very 2-3 projects which are very much related to this. One is economic impact of production technology released by US GKVK. Almost all production technology, 500 technology, that agriculture technology, that include all livestock, varieties, whatever we are exploring now. It is almost 500 technology we have covered. And last 30 years, this project is my head and myself was associated in this project. This is actually public investment, how the agriculture university is contributing to the utilizing money. And all technology, 500 technology, we have assessed it. Each technology, we have given very key factors, like what are the limitation, negative sides and as well as the positive sides to adoption, and why have not adopted those technologies as released. So this report is available in my Department of Agriculture Economics.
You brought it today?
No, madam, but it's only I brought soft copy. It is with me, so we'll be sharing. And this is because I am basically agriculture economics, agriculture scientist, which we have worked. And secondly, our Professor Pramod sir has explored AI in agriculture, new technology, which we adapted in my own personal farm. That is automation, grape technology. We using the remote sensing, all those, including spraying, sir, fertilizer, and soil health related activity, everything we will get in fingerprint, madam, which I have adapted in my home. I do my grape cultivation. Till today, I am giving advice to my brother. He is doing all related to package of practice craft. Is I am means I only adapting. So visiting frequently once in month or 15 days. So that is second one, and I have shared the few picture of our director sir regarding these drone, how it is used. So already I had taken key from my professor. Actually, I went to the my field, but drone has given a very big advantage to the planting, high tall plant people than these small crops and all those things. Because very limited people they are using spraying and all those things in areca nut, coconut. Spraying is very difficulty. Even the giving the foliar spray of nutrition. These chemical fertilizer people they are turning from solid fertilizer to the liquid fertilizer now. That's why they are investing free of giving a drone and all those activities. But these some of the things I have used. Very limitation is we have to train them in pilot. Some of the people they don't know how to avoid the obstacles, fixing the radars and all those things. Actually, along with this company, I went and tried to the field demonstration. I shared a picture with you how the radars can be controlled and the line of margin. If this is my field in this side, that side is another field. If you fix the radar here, it won't go to even though it can't spread to outside that field. So that much of very highly technical part is there in the drone. So these are the things, and third one is actually that Indo-German project, which is also associated in the Agricultural University. We have done this genetical and seed breeding capacity, means we have the happy seeders and all those things, including biofortifications. Many studies are there which will help you for the in longer. Thank you, sir. Thank you for giving this.
Thank you. Thank you. So one question which you have said has just come in my mind, which we have not put anywhere, is issues like land conflict or other. The drone goes and sprays something on your neighbor's field, and neighbor is not growing grapes but is growing something else. And these are the ground level social and economic issues which we have to keep in mind. Yes, Pramod.
Well,
You go.
this is very ambitious program. Just evaluating the 20 years contribution of CGIAR. And CGIAR is not one or two institutions, almost 20 institutions, probably 15, 20 institutions.
10, 11 in India. 11 in India.
You're covering up all those working in India. So 10, 11 also.
Yes, yes, a lot.
And the problem of such evaluation is when you have 10 institutions working from the most of these are having their head offices abroad. ICRISAT is in Hyderabad. IFPRI has a station here, but IRMI, IRI, and many other they are all abroad. Now, when they start working here, they may be claiming some new innovation. None of these institutions is working standalone.
Absolutely.
Yeah. Everything they bring in, the first thing is Ministry of Agriculture or the other maybe forestry or fishery department or whatever. And then there are state agriculture universities. At the top of that is state government, which even if the central government Ministry of Agriculture is working, they also take state government along. Because anything you want to implement in the field, there will be there are multiple institutions. Now, any claim of CGR contribution, separating out contribution of all these institutions and saying that this is the contribution of CGIAR, that is going to be very, very tough. I don't know what method and in what way you can say that this is contribution of CGIAR. Maybe their contribution is 50%, 50% will be the other partners. And in many of these cases, I find if CGIAR wants to implement something without the cooperation of all these other institutions, other departments, government, everything, I don't think their success will be even 10%.
So, I want to say something.
Yeah, there. So please come a little.
Actually, recently there was a call. It was about 1.5 years back by Minister of Education. That is about call for proposals for AI in agriculture. And there was a consortia, so they wanted to set up a center of excellence in AI in agriculture in Pittsville. So I was part of it, and then they shortlisted about 4 or 5 institutions, and they said, "We will give you 2 crores, and you all contest for the final 300 crores project." And actually, we narrowly missed that. It went to IIT Roorkee. They got 300 crores project on AI in agriculture. So I don't know whether they have any collaboration with CGIAR institutes. And what we said, and we want to use a lot of remote sensing data and soil analysis. And remote sensing data would help in number of ways because we have numerous satellites, and some satellites really work for studying the soil quality, soil characteristics, and some of the hyperspectral remote sensing data. We have hundreds of channels. Some of the channels are specifically meant for studying the hydrological aspect. Some are good for studying a specific plant species. And to that extent, people are mapping. So with very high accurate things. And keeping all these things, we have proposed a proposal. But we got 2 crores with pilot project. But 300 crores project went to IIT Roorkee. But I'm sure that if somebody approaching IIT Roorkee, what exactly, but I don't think they are really domain experts. They are all engineers mostly. But your knowledge is used there because otherwise it is this precision agriculture, even IIT Tirupati they got. 100 crores technology innovation hub.
Yeah, yeah.
What we got was data sciences. They have taken back money from Indian Statistical Institute because we couldn't meet their requirements. Because they wanted us to set up a Section 8 company, and then they were not happy. But IIT Tirupati is doing well, specialized in precision agriculture. I don't know whether they have any kind of collaboration with CGIAR.
Thank you.
Exactly, that is what I'm saying. You have 300 crores.
Yeah. And
That
they have
goes-
they're spending 5
goes to
crores.
probably the experts are sitting elsewhere. They don't have the brand name. So they don't get the real things to contribute. Something who is not having the expertise gets it, gets the mediocres, put them on job, and will be producing something. Coming back to this, let me finish. Coming back to this, that is the first question. Probably you need to have this thing in mind, how you are going to separate out the contribution. Then you have the 20 years period. If really you have the plans to go to the field, of course, something which was done in 2005 or 2010, even if today I am going to the farmer, asking on that technology which started, and probably now we are
the next stage,
the third stage of the technology. Will there be enough information available, or you would be able to extract what was the situation at that time, and how much that innovation contributed to this? Because today, if you go and ask how the extension activity was done, there were scientists, they were approaching. Now they have the mobile phone. Everything is coming on daily basis. So how much they were getting on daily basis at that time is very much difficult to measure. So the what our Australian partners they were indicating that counterfactual and all that. Will that counterfactual be available for the past? If we are doing for 1 year, 2 years, the recent period, you have the counterfactual. But in the case of 20 years back, I don't know counterfactual where it will come from.
Don't discourage us too much.
I am not discouraging. I am bringing this.
I think there are 2 people waiting online.
They have to be prepared. Then the before and after situation, those circumstances is not available. Then, we have evaluated RKV, Rashtriya Krishi Vikas Yojana for 28 states, entire country, and the projects include the infrastructure projects and the other projects where you can easily measure the impact of certain projects is not time bound, and mostly initially 4 or 5 years you are spending a lot of amount without getting measurable outcome. The outcome may come after 20 years because CJR is contributing in those areas where getting impact is very difficult, and then also you have to make a difference between impact and outcome. Impact is something you can have in the short run, but outcome is a longer, bigger contribution. So I think
come back to you. Let's just finish the online. So Dr. Aravindan and then Gaurav.
Yeah, hi. Thank you so much. I mean, quite happy to be part of this discussion. I have a few points, both in terms of the initial stock take that has been done in terms of the sheet that was presented, as well as some pointers for the other surveys and data that will be conducted. The first thing which I would suggest is perhaps evolving a better typification or a typology of the innovations used would be very helpful. For instance, not just saying that soil health management is natural resource management, but going beyond it. Is it process-based? Is it extension-based? Is it crop-based? Essentially to distinguish between, for the same type of field, whether it is a process, like let's say the difference between biofortification and genomos versus the insurance tool or the UTM-5 program, which was earlier mentioned. This will also help create certain categorical variables which will be useful for determining causal impacts later on in the analysis. The second thing is, further in terms of data collection or analysis, I would request that maybe when the emphasis on scale is not just in terms of the adopters of the technology in terms of size class or land size class, but also scale in terms of, let's say, the technological operation. What is the minimum extent in which a technology is being used? What are the economies of scale, operational costs? Those are also important scale determinants, which sometimes do not get covered in these studies on agricultural innovation. The last, perhaps, is more related to maybe some of the qualitative data that you will conduct. Definitely in terms of a better understanding of what are the drivers of technological adoption, older forms of technology that are being replaced. The second is that when we evaluate some form of efficacy or efficiency of this innovation, it should not just be in terms of let's say, a standard metric of yield or increase in productivity, but let's say something a bit more general in the area in which something is adopted. So if 80% of the crops grown in a particular area are a particular strand of GM, has this resulted in closing the yield gaps or not? That would be a far more greater measure of efficacy. And finally, this something close to my own research is if there's any emphasis on risk perception, which is beyond willingness to pay of farmers, then it will greatly add to this whole field. I think that's something which has really been missing, at least in the Indian context. So those are my broad suggestions. I can definitely email them also. I've written some of them.
Thank you, Aravindan. Gaurav?
Yeah. Yes. No, I just, first of all, thanks for some of the comments and the discussion. I think these are very useful things. I just thought I'll just comment on one or two points which were raised earlier. This issue of, that I think it'd be fair to say that we are not in the business of attributing applauds or blame as the motive for this exercise. Of course, for any of these things, I think the point is very well taken that there are many actors involved. CG centers may be one of the actors, but we have to, they have to work in India, and there are so many agencies involved at different tiers of government, etc., and so on. So I think the idea here is really something that a piece of technology or practice or innovation that may have originated or is related to CG-based research. So it has some link with the CG system. Whether it succeeds in India or not, it depends on so many factors in India. So in fact, that would be the next stage of analysis, that if we focus on a few of these interventions, which are quote unquote CG based, that doesn't mean that CG can take the full credit for their success or take the full blame for their failure. Once we've done that, then I think the next stage would be to look at the factors that contributed to the success or failure, which may have to do with a number of different actors and institutions, factor markets, all kinds of things. There's a whole sort of political economy, sociology, and of adoption that is relevant, and lots of factors. So I wouldn't be too worried about the issue of we are not in the business of attributing blame or applause for that matter. I think the other points that are raised are difficult ones. Actually, they really are challenging. 20-year time span issue is a big challenge, and I think we'll need to think very hard about how we think about that issue. And also the point, I think, that about the impact takes time. That is also well taken, and these are really some of the things we'll need to consider. I'll just say very quickly, because the time is short. I think the impact evaluation part is a little bit still quite a bit further downstream yet. We are just starting up, but it is important actually to think hard about the impact, about thinking about impact, because it should inform our data collection. So in some ways, you want to be clear about what you want to get to, so that we don't collect data which ultimately they say, oh, with this data we cannot answer this question. So in that sense, really appreciate the comments that are being made, and we will take them on board, and some we'll have to think hard and maybe consult with you all again to think clearly about it. Thank you.
Yeah. Agreed, Gaurav. We'll have to have many more consultations. So I'll ask Dr. Soundarya to say a few words and then Jayaraman. Yeah.
Okay, just very quickly. So I was
Vivek Cloudly is soft spoken.
I was reflecting on what Professor Pramod said and what Tapas also presented in the in the stock taking exercise. And what sir was saying was that before 2000 there were about 50 startups, and now there are over 1,000 startups. Many of these startups are also located in Bangalore. So I was also wondering, there was also a report I was reading a couple of days ago by Transitions Research on AI on the ground, and they're looking at different sectors, agriculture, healthcare, and a whole range of sectors. One of the methods they use to look at which are the companies working in this space is to shortlist companies from databases like Crunchbase and AngelList. I don't know if that will be helpful in your stock taking exercise when you're shortlisting. Many of these companies may be working with the government and with CGIAR as such. So that was something from the startup. If you can approach it from the private side.
Angle.
Yeah.
I think the scope of our research is expanding with every speaker. Over to you, Jayaraman.
Just give me a sec. Yeah. So that was a very interesting set of presentations. And I must say, though, I thought in the beginning from the presentations that the impact evaluation would be sort of easy to formulate. But I think the point raised about the fact that the CGIAR research doesn't take place in a vacuum, the point which has been made repeatedly, and that there are multiple players, and what is the distinctive stamp that CGIAR has contributed could then become very difficult to determine. So I think one possibility is, of course, if there are very distinct innovations, they would not be many in number, but it would be sort of give an idea of the kind of impact which is there. And so that perhaps would be one way to look at it. The other, I think it is still very open. What kind of data collection would ensure that this is done? And what about all the other innovations where there are many actors pursuing similar innovations? So I think that is now an somewhat urgent question to solve. I think I would re-emphasize Arvindan's point about the importance of risk perception in the adoption of technologies. And this goes back, there is a very sort of very respectable literature on this, going back to Binswanger and classic papers. So I think we see a lot of this, and especially there are repeated field reports of the farmers, if they are not able to get varietal replacement, if varietal replacement is not proper, then farmers fall back on traditional varieties. So sometimes this is celebrated, but it is not exactly speaks to the value of the innovation. So I think what is the role of risk perception and the way farmers react to risk is, I think, is an important aspect of this in barriers and enablers to adoption. If you want to put it generally, risk is a major barrier and risk management, overcoming risk. We are familiar with finance, etc., but looking at other dimensions and the qualitative aspect which was suggested in the presentation on methodology, I think can play a very useful role here. I must say, having heard remarks about large language models and AI, I would urge considerable caution, especially in literature search. There have been recent evaluations because of my own interest in large-scale literature search. We have been examining this. The most recent literature still says that if you use large language model, generative AI, etc., and you begin with different seeds, you will get different responses. So I think it's very problematic. It's a very different thing to use machine learning methods which do literature searches in more sophisticated ways of using keywords, etc. So if you have an identified body of literature extracted from, say, Web of Science or some database of agriculture science publications, then I think, or you could even run it on a website if they would provide you access. That would be something which you could do. So I think real caution is called for. And overall, I think the big message, I think, from this discussion is that some restriction of the scope of work, some limitation, some boundary is called for. I think that is your major message. I mean, I did not anticipate it myself, so it's something that I also learned from the inputs that we have been hearing. I'll stop here, and all the best for the project.
Thank you, Jayaraman. So, I think if there is anybody else in the room who would like to say something, Nosha, please. Yeah.
No, I also, when you look at the stages, when you talk about access and then adaptation, and especially when you're talking about digital technology, recently a national level survey has been done, the level of digital infrastructure across in various states and the thing, because it is easy to demonstrate in one level. There are many of these technologies may require a 5G level of connectivity and other things, which is not available in many parts of the country. So you could actually use the data. It's a national survey, state level data is available, so you can also integrate with that.
Thank you. Sherry, would you like to say something? She's also on our project team.
Not much. My discussion on DNA fingerprinting and part, I think in the earlier SPIA meeting was already done. And if anything comes up, I think I can discuss individually. Now we are already, I think, behind the schedule. So please go ahead.
Yeah. We're 2 minutes away from our lunch. I think we're all feeling hungry. Let Pramod say a few words. Yeah.
I just wanted to give one more caution. There are various stakeholders. When you talk to different stakeholders, there are different claims. You talked about this Bhuchetan. When I was speaking to advisor to Chief Minister, almost 2 hours, he has painted a picture of Bhuchetan has transformed the Karnataka agriculture. It has a huge impact. When we went to the farmers, they don't know what is Bhuchetan. Nobody has gone to the field to have the sample. Similarly, there are many things where government claim is totally something in the air, but at the farm level, nobody reaches to them. So we have to be very, when we say the contribution, that has to be just from the farmer, not from the claimants. Yes.
I think that's the major objective of the project.
No, I think what is being said here is, when we say what has scaled up, even Bhuchetna, I thought when we were in ICRISAT, so many million hectares of watershed, etc. So we may shortlist it based on the scale of the data given by the organization or the government And actually that is, so it's very relevant even in the first step of shortlisting. And then of course, when we go to the field, we'll get the truth of what and what is not being used. But this, in fact, Tapash mentioned it, but I think it's a very important point, and which is where we know this, I hope this group and others who couldn't come today can contribute, which is that from the long list, when we want to get to the short list, we want to know what is new, is it new, is it observable, and has it really reached scale? Not in the Aravindan sense, but has it really reached a significant number? And in India, I think that, significant, of course, we can't say 10,000, 20,000 is significant. We have to look for bigger numbers. I mean, we don't have a cutoff. And here, I think the data gap filling, what they call data gap filling, is talking to people who know the field and getting their opinion, because all of you have worked in different projects in different parts of the country. You can say that what you just said, that Bhujetana is not all what it is. Huh? So I think this is very important part of the first stage itself. Not of the survey will tell us the truth later, that who is using it or not. But even before that, so Sujit, why don't you come back, because you gave us a lot of innovations, and we can. I think we can delay lunch for 10 minutes. Yeah, please.
No, I think the Bhujetana thing is relevant because I also know.
See, let's take other example of engineering. So much billions of rupees spent. How much irrigated area?
Okay, let's Sujit.
No, I think that point is very important because you have an innovative technology and then you have partners, state and other system which implements it. It's also important to get a response, to get a reflection from that side also. So the consultation process, the final selection process should get a feedback from the partners also. I think that is also important because Bhujetana thing, like there are several other things which will not get into the list. And also it's very important to define a CGIAR innovation, because Plantics, to my knowledge, is not a CGIAR innovation. It's it's an company which is divided. So the innovation of ICRISAT maybe they use that for standardizing images across the crops which they are focusing. Pest and disease controlling in pigeon, chickpea and all, and then so you cannot characterize that as an innovation by CGIAR. Plantics is not an innovation by CGIAR, but then the use of that's part of a digital agriculture strategy. You use digital agriculture technologies to make to bring benefit to farmers. Okay, so that when you define it as a CGIAR innovation, you have to be careful about that.
That's what I feel. Very helpful. Thank you.
But as per the definition, it's like a contribution of the CGIAR.
It's a wide net definition that they have kept.
Plantics is not CGIAR contribution.
So,
yeah, I think when Bhujetana kind of problem is that I think when government says something, there will be some data backing up. We have to demand that. I think we have to interrogate them, as I said. We should talk to them, no doubt. But we should interrogate them. On what basis are you saying? Where is the data? Where from it is coming? There will be, somebody says so many numbers, there will be some basis.
Yes.
So that's the way we have to. Yeah. We can't leave them out.
Absolutely. No, we have to consult governments. We've put in agricultural universities and NARS because they are the first level partners with the CG system. But then for dissemination or any scaling up, it has to be the governments in India, the different ministries. So, as I say, how many governments and how many ministries, but I think the point here is very important that administrative data from the government has so many wells dug, so many NREGA pumps made or whatever.
Recently, we talked to the Emprey, thing they gave.
Yes.
They are setting up district level, the training, collecting data. So it's not just empty.
Yeah.
Some of it may be product.
Ultimately, percentage of area irrigated, if it has not increased even by 1%, whatever you are claiming is our claim.
Exactly.
I want to say something.
Yes, please.
Recently, after 75 years of our ministry and our planning commission you mentioned that now the data will be available at the level of states. So hierarchy, like a zonal level and then state level and then level all of that. And is there any CGR body using that kind of data in quantitative sense? Sometimes there are certain quantitative approaches. We should say that any quantitative approach that we use will be very innovative. For instance, we used to teach and use in some of our research, mostly a kind of spatial econometric approach. The technique known as spatial autocorrelation technique, which was provided by PLP Moran of Oxford University almost 60 years ago. Its utility has come up only about 3 decades ago. And so nice, it is like district level, taluk level, you have GDP values, primary, secondary, tertiary GDP values, and you can find out which district or which taluk is having a kind of inequality or a social disparity. And because that number will tell us, and if the number is towards 1, and we say that it's a perfectly aggregated. If it is, the number is towards -1, it is perfectly disaggregated. And these disaggregations are actually tell us social disparity, inequalities. But having data, if it is really precise, probably from our ministry, they are telling that at district level we'll provide the data. NSSO is telling. Using these ideas, I should say that there are powerful innovations. And I have seen one of the persons who canceled from School of Spatial Econometrics from Chicago, and he was the one who developed the case called Geoda, and it has all powerful routines. And sometimes sitting here and then making a policy, sometimes it may be very subjective. But the kind of data using a technique like Moran's index is so powerful, and it tells us. You can always say that if it is really wrong policy, yes, Moran's index is not wrong. Moran's index approach is very, very robust. But using that and getting the index calculated and domain experts interpreting that, yes, it is true that these districts are having a lot of social disparity, whereas these districts are highly aggregated. The rich flock with rich people and so not the other way. And then can we really find out, segregate the regions, highly aggregated, highly disaggregated, and highly random. So I felt that actually Rashtra's thesis is one of the chapters with Moran's index applications on the GDP values. And similarly, which two districts are interacting well in terms of a specific variable. So well interacting and feebly interacting. Newton's gravity model people will use as social gravity model, but it has a location component. It is not that we travel to the city outskirts to buy something. We try to go towards city center. Ultimately, what matters is the location. I believe bringing all those things with powerful data that we have are really innovations. I'm sure that some of the organizations are using it.
But generally,
Thank
government
you.
may have that data, but they are not ready to.
Yeah,
Well,
well, our ministry itself is not releasing data to us, so I don't know. In fact, just on closing, that in many of the other countries, these sample surveys are part of the national statistical surveys. But we said to persuade NSS to change their questionnaire, we'll take 20 years, we'll all have retired by then. So anyway, thank you very much. It's been a very interesting morning, and particularly to those who have come from outside, and Surjit, you have come all the way so from Hyderabad. Thank you so much. But I also want to say in closing that this is only the first discussion, and we will actually be now sending emails to all of you for all your reports and further ideas and suggestions, and also perhaps interacting once we have this set of innovations, because I think this whole thing about the typology, Plantix is not, we can't, under digital, and then under digital we would have to see, it's not Plantix, but perhaps Plantix for the dryland areas. That is the innovation, bringing in the information that ICRISAT has on the dryland crops or their mandate.
Plantix may be private. The knowledge base it uses.
Yeah, exactly.
Digital is a platform.
Yeah.
Most of the innovation is captured by the private, and that is how the absorption also
Yeah. So I think this.
As long as they use the knowledge base to result the formula, then it is still a constitution.
That's right. So I think the categorization is a knowledge based. That is very important. The typology of innovation, because this is something that can be used by others later on. And we are, I think, perhaps in our first visit, we are now using the typology they gave us, because they gave us a nice typology and we felt happy and we used it. But we really need to reflect on that with the experience of others here and some who couldn't make it. So thank you all once again. Thank you to Monash for staying on, although we are in good Indian style, delayed a little bit, but not too much. And we are going for a nice lunch. I hope you have a nice evening. Gaurav,
Thank you very much. Yeah, and it was a very useful meeting, and hope to follow up on some of the discussions, of course.
Yeah.
So thank you.
Okay. Bye, everybody. Bye.